In this you can see the input is X, the output is Y, and the two flip-flops are used, and both the flip-flops are D flip-flop, and also gates are used as our combinational logic, the input combinational logic and the output combinational logic. So the first step, let me write it down. This step number 1, step 1, and in step 1 we will find out the input and output equations. We will find out, let me slide this board a little bit, the input and output equations. Now what is this input and output equation? We will find out the expression for dA and dB, which gives us the input equation, and we will find out the expression for y, which will give us the output equation. So these three things we have to do now. So let's start with it. Let's find out the value of dA, the expression for it, and it is the output of this OR gate. Now you can see the input X is one of the input to this AND gate, and the other input you can see is QA. QA is given here as the other input. So here the output of this AND gate is XQA. Okay, and this XQA is now acting as the input to this OR gate, and the second input you can see from here is QB. QB is going like this as the second input. So overall this is QB. Overall my dA is equal to XQA or QB. So I will write my input equation for dA equals to XQA or QB. Similarly, you can find out the expression for dB, and it is the output of this AND gate. The first input to this AND gate is QB, from here you can see, and I will write QB here. Similarly, the second input to this AND gate is QA, and then because of this NOT gate, complement. So the second input is QA complement. So the output here is QA complement QB. So dB, the expression of dB is QA complement QB. Now we will move to the output equation, the value of y, the expression for y. So for that we have to find out the output of this OR gate, and the input to this OR gate is the output of these two AND gates. So the first thing that I will do is to find out the output for these two AND gates. Let's see for this AND gate what is the output here. The first input you can see is QA directly, so QA, and the second input is X. X is coming like this and it is given to this gate, so XQA. And for this AND gate, the first input is QB complement and the other input is X complement. So here I am having X complement QB complement. Then we have to OR this two things and we are having our y. So I will write y equals to X complement QB complement or XQA. Now in this way I have my input and output equations and our step 1 is completed. The next thing is to make the state table, which is our step number 2. So let's make it the step number 2, that is the state table. You already know about the state table, what are the different columns involved in it, and if you don't know, there is no problem. We are going to make one state table for these input equations and output equation. The first column consists of the present state, and the present state is what? QA QB. The second column will have the input X. The third column will have the next state QA plus QB plus. This plus represents it is the next state, and the last column is Y, that is our output. Now a very important thing comes is the value for the next state. What will be the value of the next state? We know our qa and qb, we know our input x, and depending upon this qa, qb and x, we will have the value of y from this equation. But how we are going to find out the next state? You have to just remember the lectures when we were studying the flip-flops, and when I was explaining the d flip-flop in the characteristic table and the excitation table, I told you that the value of d is equal to qn plus 1, where qn plus 1 is my next state. Similarly, if I talk about the next state value of my a flip-flop, it means qa plus, it is equal to dA. Similarly, if I talk about the next state of qb flip-flop, it is equal to dB. And from the input and output equations, we have dA, we have dB. So we have qa plus and qb plus. In this way, we can find out our next state. So let's fill this table, and let me draw this separating lines. There are total 8 possible combinations. I will show you, because there are 3 variables qa, qb and x. So there are total 8 possible combinations. I will tell you how to find out the value of qa plus, qb plus and y, and then rest of the cases you can handle. Finally, we will move to the step number 3. So let's fill this 0, 0, 0. Let's see this first case. When qa, qb is 0, the input is 0, then what will be the next state and output? qa plus is equal to dA, and dA is what? dA is xqa, xqa or qb. So qa is 0 and x is 0, so I will write 0 and 0. qb is also 0, so overall I'm going to get 0. The value of qa plus is 0, so I will put 0 here. Similarly, qb plus is equal to db, and it is equal to qa complement and qb. qa complement means 0's complement, it is 1, and qb is 0 already, so I'm having 0 as my next state value for the b flip-flop. Then we will find out the value of output y. Y is equal to x complement, x is 0, so its complement is 1. qb complement, qb is 0, so its complement is 1, and xqa, x is 0, qa is 0, so overall I'm having 1 here. So the output in this case is 1. Similarly, we will do for the next case when qa is 0, qb is 0, but x, our input, is 1. In that case, if you see x is 0, let me do it in different color so that we can differentiate it. X is 1, so 1 is here. qa is 0, so 0, qb is 0. So overall I'm having 0, 0 here. Similarly, we will find out for qb plus. qa complement means 1 and qb is 0, so again it is 0. The output y, let's check for it. The output y, x complement, it means 0. qb complement, it means 1. X is 1, qa is 0, so it's going to be 0. In the same way, you will do for the next 6 cases, and they are 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. You have to find out the value of next state and the output. You can do it by yourself. I am just going to fill this, and then we will move to the step number 3. I have completed this table. I hope it is same as yours. This is the table, and now we can move to the step number 3. Step 3, and this is the final step. In this we will find out the state diagram. So let's start with it. There are 2 flip-flops, so definitely there will be 4 possible states. I have already explained this thing in the initial lectures. The 4 states are S0, and in that case the value of qa and qb will be 0, 0. The second state is S1, 0, 1, S2, 1, 0, and S3 is 1, 1. So let's make these states. I will make 4 circles for this. Okay, let me make it a little bit bigger. and this is our fourth circle. And this first will represent my state 0 as 0. So 0 0, this will represent S1, so 0 1. This will represent S2, so 1 0, and this will S3, so 1 1. Now the role of the table comes. We have to make this state diagram depending upon this table that we just evaluated. And you can see when QA QB are 0 0, it means I am here, and I make the input, the value of x equal to 0. Where I am going? I am on the same state. The next state is also 0 0. It means if I give the input equal to 1, so input is 1, and you can see the output is also 1, so output is 1. Very simple. Similarly, we can analyze for this case when I am on S0 and the input is 1, x is 1, then I am again on the same state, so I will write what 1 and the output is 0, so 1 0. Now let's see this case when the value of q and qb is 0 1, it means we are on S1, the input is 0, and we are moving to 1 1. It means from S1 we are going to S3, and it is when the input is equal to 0 and the output is 0. I hope you are getting these things. Now let's see this case when we are on S1 0 1, it means we are on S1 and the input is 1. Then again I am moving on S3, so I will write 1 0 because 0 is the output in this case. Now let's see for this case when I am on 1 0, 1 0 is my S2, I am here, and the input is 0, and it is making me to move to 0 0. It means the next state is 0 0 like this, and the input is 0, and you can see the output is 1, so output is 1. And for this case when I am on S2 here and the input is 1, I am again on S2, so the same state when the input is 1 and output is also 1 in this case. Let's see for the second last case when I am on S3 1 1, input is 0 and I am going on 1 0, it means I am going on S2, input is 0 and output is also 0. Let's see for the last case when I am on S3 1 1, and when the input is 1 I am going on 1 0, again I am going on 1 0, so the 1 input is also making to go from S3 to S2 and the output is 1 in that case. So this is the state diagram for our circuit, and I hope all the 3 steps are clear to you. These 3 steps are required to make the state diagram of any sequential circuit. So this is all for this presentation. If you have any doubt regarding this, you can ask in the comment section always. So I will end this presentation here. See you in the next one.